and statement 2, and statement uh, 3. So like that, like that. So let us assume there are so many statements are available. So let us assume there are so many statements are available inside the program. So I can call these are the statements uh, n. So I can call this as a program. I can call this as a. So already we know that any program so can be divided into multiple processes. So directly system cannot execute. So directly system cannot execute the program statements there. So instead of executing program at a time, so the process, so the internal processor, so divide a program into processes, program into processes. So let us assume these are processes. Let us assume these are processes. So I can call, I can call these are processes. So process one and process and the process and the process. So entire program is divided into multiple multiple processes. So let us assume, so this program is divided into multi processes. So I can call this is a process one. This is process one. I can call this is process one. And it contains some of the statements. So let us assume one, two, uh, three statements are available, and this is nothing but process two. This is nothing but process two, and it also contains some four to six statements are available, and this is called as process three. Process three. So let us assume from seven to a program contains the same statements. An entire program is divided into multiple processes. So these processes simultaneously execute by the processes, executable by the processor. So let us assume this is a processor. Let us assume this is processor. Let us assume this is processor. This is processor. So processor will execute processes. So processor will execute processor will execute one by one. So processor will execute the process. I will write here. So don't be confused. The processor will execute the processor will execute the processes. Processes means the program are split into the program are split into multiple parts. The program are split into multiple parts. Program split into multiple parts. That multiple parts are called as processes. That multiple parts are called as processes. So the processor will execute processes. The process will execute the processes. So that is nothing but the program is splitting into multiple. This is called as multiprocessing. This is called as multiprocessing. This is called as multiprocessing. So there is a disadvantage. This is called as multiprocessing execution. This is called as multiprocessing execution. So multiprocessing execution or 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 so we can also call as or we can also call as process-based execution. We can also call it as process-based execution. Process-based execution. So A program can be split into multiple processes. A program can be divided into multi processes. The processor will execute the processes one by one or simultaneously. So this is called as multi-processing execution or multi-process-based execution. So there is a disadvantage if I execute the processes. If I execute the process. In the process-based execution, there are some disadvantages. There are some disadvantages. So what are the disadvantages? If processor execute the processes one by one. So there is a there is a disadvantage. The one process is depends on another process. One process is depends on another process. So one process is depends on another process. So until and unless the process is completed, the until and unless process is completed, it cannot comes to process two. It cannot comes to process. So that is the reason why. So process-based execution is not good way to execute the program. It's not good way to execute the program. So that is the reason why. So process-based execution. So process-based execution. So will not be considered. The process-based execution will not be considered. So because of one process is defined as another process. One has depends on such another process. So and and so there is another important also disadvantage. So one of the major important is one process is depends on the another process. And so another one is so only only the single or common area. Only common area uh, can be shared. Only common area can be shared among processes. Among process. So only common area can be shared with the among the processor. So due to all of very memory inconsistent results, inconsistent 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 result, inconsistent result, inconsistent results. So this will cause you inconsistent result. So one process is depends on another process. Only common area can be shared among the processes, and inconsistent results will be appear if we follow the multi-processing. If we follow the multi-processes. If we follow the multi-processing or process-based execution. For this process, the program can be divided into multiple parts. The program can be divided into multiple parts. So I have declared the process one, I have declared the process two, I have declared the process three. It contains 1 to 3 statements, it contains 4 to 6 statements, and it contains 7 to 10 statements. So that means the program contains 10 statements. The program contains 10 statements. The 10 statement is divided into a subpart of program. Suppose 1 to 3 statements are available in the process one, 4 to 6 statements are available in process two, as well as 7 to 10 statements are available in process three. So process will execute the processes. So that is called as the processor will execute the processes. That is called as process-based execution. So in today's generation of the computer, the processor will not execute the process-based execution. So because of one process depends on another process, only common area can be shared among the processes and inconsistent result. So to overcome this disadvantages, so Java is come up with a new concept called as threading. So new concept is called as threading. So if we execute multiple threads simultaneously, if we execute multiple threads simultaneously. So that is called as multi-threading. That is called as multi-threading process. Multi-threading process or multi-threading programming. So we can say multi-threading programming. So what's the thread exactly? What is the thread exactly? Again. So I can display again. So let us assume, so we have the same program. So let us assume we have the same program and same process. We have the same program and same process. So same program and same process, same program and same process. So, but here, so one process can be divided can be divided into multiple threads. Can be divided into multiple threads. One process can be divided into multiple threads. One process is divided into multiple threads. So this is nothing but a process can be so converted into multiple. A process can be so divided into multiple threads. So executing multiple threads simultaneously, executing multiple threads simultaneously is called as multi-threading. Is called as multi-threading programming. Multi-threading programming. So I can say these are threads. I can say these are threads. So thread one. Right. Let's assume thread two. Let us assume thread and this is thread 4. Now this is thread 1. So let us assume this is thread 1. This thread 2 as well as thread 3, thread 3 and thread 4, thread 4, uh, thread 5, thread 5 and thread 6 and thread 6. So what is a multi-thread programming? Is executing multiple threads simultaneously. So who will execute? The processor. Who will execute? The processor. Execute the processor. Who will execute? The processor. Executing multiple threads simultaneously is called as multi-threading. Is called as there are two or three definitions. The first one is program, and the second one is process, and third one is thread. Third one is thread. So executing multiple program is called as multi-programming. Executing multiple program is called as multi-programming. So executing multiple processing is called as multi-processing. Executing multi-thread is called as multi-thread programming. Multi-thread programming. What is programming? The programming is nothing but collection of statements, collection of statements or instruction. Collection of statements or instructions is called as programming. It's called as programming. The program can be the program can be so split into program can be split into multiple multiple parts, multiple parts. That multiple parts of the program, multiple parts of the program is called as multiple parts of the program is called as processes. Processes. That is process. That is process. A multi-program can be split into multiple parts. That is nothing but process. A process can be a process can be collection of, or we can say the process is nothing but collection of, or we can say, or we can say, or we can say. So the process is nothing but collection threads, collection of threads, collection of threads is called as process. Collection of threads is called as process. So what is thread? A thread is it is a nothing but it is nothing but part of process. It is nothing but part of process. It is nothing but part of process. Or we can say lightweight component. Or we can say lightweight component. Lightweight component. So process can be called as like heavyweight component. Heavyweight component. So what are the weight here? What are the weight here? Heavyweight component and lightweight component because when compared to the threads, so lightweight lightweight components, lightweight 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 components, lightweight component, lightweight component, and heavyweight component. So, what is the meaning of component? What is the meaning of lightweight and heavyweight? The program is called as collection of statements and instruction. The process is called as the program can be split into multiple parts. That is nothing but process or collection of multiple threads or collection of multiple threads. So, or we can say heavyweight component, or we can say heavyweight component. And what is thread? The thread is nothing but it's a part of process. It is a part of process and lightweight component. It is a part of process and lightweight component. So what is the meaning of heavyweight and lightweight? So you can see the diagram here. You can see the diagram here. The statement, the program contains 10 lines of code. The program contains how many lines? 10 lines of code. Let us assume there are 100 lines of code. There are 100 lines of code. So when it comes to the process, it will convert all the it will convert the program into multiple processes. It will convert the program into multiple processes. Let us assume each process contains 20 lines of code. Each process contains 20 lines of code. And when it comes to thread, the 20 lines can be converted into 4 or 5 lines. 4 or 5 lines. So now the 4 or 5 lines are light. 4 or 5 lines are light, and the 20 lines are heavy. And 20 lines are heavy, and 100 lines are more heavy. So I can say so thread is a lightweight component and process is heavyweight component. The process is heavyweight component. The process is heavyweight component. So when compared to the threads, so the process will have the heavyweight. The process will have the heavy weight. So So coming to the point, so compared to the process like this, so thread is very light. So it contains only 4 or 5 lines. The process contains almost so 20 lines or let us so scenario. So that is then why a thread is a lightweight component. So you can write any statement, the definition for the threads. What is the thread? Thread is a part of process, or you can lightweight component. A thread is a collection of small amount of data. So there are two types of execution. So process execution as well as thread-based execution, as well as thread-based execution. So what is process-based execution? A process will execute a process execute the processor executed the processes. That is process-based execution. The process executed by threads, that is called as thread-based execution. That is called as thread-based execution. So there are two types of execution. So process-based and thread-based. So process-based and thread-based. So if process execute the processor execute the processes, that is process-based execution. If processor if processor execute the threads is called as thread-based execution. Is called as thread-based execution. So executing multiple threads, executing not a single thread. So there are multiple threads. Executing multiple threads simultaneously is called as multi-thread. Is called as multi-thread programming. Is called as multi-thread programming. So executing what is multi-thread programming? Executing multiple threads simultaneously. Executing multiple threads simultaneously is called as multi-thread programming. Is called as multi-thread programming. So what is the definition of multi-thread programming? So executing multiple threads simultaneously is called as multi-thread programming. So in Java. So in order to declare the threads, in order to execute the thread, so we have two options. So we have two ways. We have two ways in Java clear to clear the thread and the thread-based execution. The first one is the first one is runnable interface. First one is what? Runnable interface. There is an interface. And the second one is there is a class called as thread class. There is a class called as thread class. And runnable is an interface. Runnable is an interface. So there are two ways to declare the thread class and execute the threads. There are two classes or two things we have. So first one is runnable interface, second one is thread class. In another way, in another way, so we can also say in another way, so we can also say so implementation of implementation of runnable interface. Implementation of runnable interface. Runnable interface. Implementation of runnable interface. And the second one, subclass of subclass of thread class. Subclass of thread class. So implementation of runnable interface and subclass of thread class. So you can also say the same thing. You can also say the same thing. So runnable interface is nothing but we should write the implementation class of runnable interface. The thread class is in a sense so we should write the subclass of thread class. The subclass of thread class. So after that. So these interface and implementation classes. These implementation classes are available in so JSC API or available in JSC API. JSC API. Stands Java standard edition. Java standard edition. We have the default package called as Java.lag. Package called as Java.lag. package. So I'll show you the implementation. API implementation. API is contains. So thread is run thread is run on thread class. So just a minute, I'll show you. Meanwhile, the loading. So go to the package folder, Java package. The default package folder, Java lang package. Java package. Java lang package. There is an folder. There's an interface called runnable. So we have one option for syntax, and there is another class called as thread. There is another class called as thread is a class, and runnable is an interface, and runnable is an interface. So there are two ways to declare the threads and executing the threads. Declare the threads and executing the threads. So declare the threads and executing the threads. So there are two ways. First one is so runnable interface. The second one is so implementation called as runnable interface. So these two are available. These two are available in so Java.lang package. So Java.lang package, which is the default, which is the default. So what we need to do is we have to define the threads. We have to define the thread. The procedure procedure to declare threads. The procedure to declare the threads and execution. Threads and execution. So there is a procedure to define a threads or declare the threads and execution. There is a procedure. There is a procedure. First, first we should write. We should write Java program. You should write a Java program to implement runnable interface. Runnable interface or or extend the thread class. Extend the thread class. So what is the first procedure to declare the thread and execution is the first one is we should write a Java program to implement runnable interface or extend the thread class. So anything fine, there are two ways. So one is implementation of runnable interface and subclass of thread class. So these are the two ways are available to execute the threads and declare the threads. So the first step is the procedure to declare the threads and execution. The first step is we should write a Java program to implement the runnable interface or extend the thread class. Second, we should override. So we should override run method. We should override run method. We should override run method. Override means already we have declared, we have discussed override means the same functionality within the subclass side, within subclass side, superclass, same functionality with same name, same parameter. So we should override run that. We should override run. And the third step, and finally, so we should call. So call. We should call start there. We should call start there. We should call start there. So what is the first step? What is the first step? So we should write a Java program to implement a runnable interface or extended the thread class. The second one is we should override the run method and we should call the and we should call the start method. So these are the three steps we need to follow. Procedure procedure for the declare the threads and execution. Declare the threads and execution. So this is about thread declaration and execution. So I will take an example. I will take an example. So declare the threads and execute the thread-based execution. So simply I can write so some sample program. So which will display thread-based execution, which will display thread-based execution. So I will take test.java test.java. So inside the file name and class name, inside the file name and class name must be same. Inside the file name and class name must be same. So test.java, test.java. So I will take public class called as a test. Public class called as test. So this class must be there is a procedure. So this class must be either should be implementation of runnable interface or extending the thread class. So this should be must be implementation of runnable interface or extending the thread class. So first I will demonstrate implementing runnable runnable interface. So I'll write a keyword called as implements. I will write a keyword called as implements. I will write a keyword called as implement, an interface called as runnable, an interface called as runnable. So open the class and close the class. Open the class and close the class. So after writing this, so I will go for compilation. I will go for compilation. So just to go to the command prompt, just to go to the command prompt, to simply write so Java C space, Java C space test.java. So Java C space test.java. So you can see the error says test is not abstract and does not override a method called as run method. It does not override a method called as run method. So what I told you, so there is three steps to procedure to execute and declare the threads. So first, we should write a Java program to improve runnable interface or extend the thread class. First step is completed. So we have taken the class, we have taken the class, and we have implemented the runnable interface. And the second one is what? So we should override the run method. So we didn't override any run method here. So that is the reason why. So it is giving an error message called as abstract method, run method. So we should write the run method within the class. We should write the run method within the classes of public void run method we should override. Run method we should override. So within this, so simply I can write system dot out dot println. System dot out dot println. Something statements I can write. So something statements I can write. So run method. So run method of a class called as a test. Run method of a class called as a test. I I so I can write the main method here, public static void main, public static void main, and some variable here, and some variable here. So public static void main. So public static void main, and open the main method and close the main method. Open the main method and close the main method. So here, so run is a non-static method. So run is a non-static method. So how to execute the non-static method? So non-static method can be executed. So non-static method can be executed. So by using the object of the class. By using the object of the class. That means so the run method is overridden. The run method is overridden within the class called as test class. Within the class called as test class. So that is the reason why. That is the reason why. So I can create a test class. I can create a test class and I can execute. I can create a test class and I can execute. So that is the reason why. So simply I can test t is equal to new test. Test t is equal so new test and followed by t dot run. T dot run. So after calling this method, I can go to the command prompt. So Java space dot Java and Java space test and Java space test. So run method is executed from the test class. But so we should not call. We should not call. We should not call run method directly. We should not call the run method directly. So instead of calling the run method, so we should call start method. We should call which method? Start method. So you can observe. So first you should write the class name, and after that we should override the run method. So which is also completed. So which is also completed. And finally, we should call the start method. We should not call run method. So in the program, so we have created the object called as we have created the object called as test class object, and we have called the run method. So we should not call run method directly. So instead of run method, so we should call start method. We should call start method. But start method is available in which class? So there are two, runnable and thread. Runnable and thread. So runnable is a interface. Runnable is a interface. So interface contains only single method called as run method. Interface contains only single method called as run method. So that I'll go to the thread class. I'll go to the thread class. I should find out. So start method. I should find out start method. So there is a method called as start method. There is a method called as start method. This method is used to current thread to begin execution. Current thread to begin the execution. So Java virtual machine call the run method of thread. Run method of thread. So when you call the start method, when you call the start method, so it begins the thread-based execution. It begins the thread-based execution. And JVM was the run method of the thread. JVM was the run method of this. So run method of the class. So start method internally calls the run method. Start method internally calls the run method. So that is the reason, right? So we should call the start method, not run method directly. Run method directly. So that is the reason, right? So start method we should call. So start method we should call. Start method we should call run method directly. So these are the three steps to execute the Java programming. So first one, we should declare Java program to implement runnable interface or extending the thread class. We should override run method and we should call the start method. So simply, to start is a non-static method. To start is a non-static method available in the thread class. Available in the thread class. Available in the thread class. So we should create thread class object. We should create thread class object. We should create what? Thread class object. So that is the reason why. So that is the reason why. So I'll go for the constructor. I'll go for the constructor. So we should create the thread class object. We should create the thread class object which takes runnable interface. Which takes runnable interface. So simply, so instead of test class, instead of test class. So you should create like this. So thread. So thread. So T is equal to new thread. So thread. So T is equal to new thread. So this is empty thread and we should supply so new test and we should supply so new test and we should supply new test. So this is called as creation of threads. This is called as creation threads. This is called as creation of threads. And after that, you can call the method called as start. You can call the method called as start method. The start method internally calls run method. The start method internally calls run method. So you can observe the statement. You can observe the statement here. So start method causes thread to begin execution and the JVM calls the run method of the class, run method of the class. So I am calling run method. I am calling start method. I am not calling run method. I am calling which method? The start method. The start method internally calls our method called as start method. So you can see the output now. You can see the output now. So Java C test.java and Java space test. So now you can observe the output. Run method is executed. Run method is executed. So which method we have called? We have called the start method. The start method is available inside the thread class. The start method is available inside the thread class. So what are the three steps? What are the three steps? So we should write a Java program to implement a runnable interface or extending the thread class, or we should override run method, or we should call the start method. So what we have discussed, the process-based execution as well as thread-based execution. So what is the difference between the process-based execution and thread-based execution? So we can see only object creation and execution, and we can see the method declaration and the object creation and execution. So when you observe the method execution, so it is like normal. It is like normal. You can't see the difference. You can't see the difference. So simple example. So simple example. So let us assume. So let us assume. So I'll write just a statement class start for name. Just a write a class start for name. So within the string. So com dot mysql dot jdbc dot driver. So this is the JDBC code which we have discussed in the last previous classes. Just I return the statement. So just I observe the output. Just I'll observe the output. So Java C test dot Java. So cannot find symbol. The symbol is called as method for name. So syntax error. The syntax error. So just for name, just for name. So CLS. So Java C test dot Java. So unreported exception must be caught or declared to be thrown. So just I'll write throws method. Just I'll write throws exception. Just I'll write throws exception. Throws exception. Throws exception. So simply, so CLS Java C Java C plus dot Java. Or I can write try and catch, or I can declare here throws. Throws exception. So Java space test, Java space test. So I have written a single statement that is class dot for name. So this class is not available with us right now. This class is not available with us right now. So I got the exception. I got this what? Exception. Exception in where? So thread. Exception in where? Thread. So run method of test. So run method of test. So you can see the term called as a thread. You can see the term called as a thread. So thread-based execution. So Java directly treated every method and every process is called as thread. So Java treated every function and every process is considered as thread. So that is the reason why. So exception in thread main. So what is the thread name? So main method. So what is the thread name? Name main method. So everywhere, so Java uses thread, but you can't really see the difference. What is process-based execution? What is thread-based execution? For example. For example, I will show you. I will show you. So I'll just write a for here. I'll just write a for loop. Int I is equal to 0. I less than or equals to 5. I plus plus I plus plus. Open the loop and close the loop. Open the loop and close the loop. So within this loop, I'll just write run method of test case. I. I. So let us assume there is no thread class and simply I can write for loop and int here I is equal to again 0. Again 0, I less than or equals to 5, I plus plus, I plus plus. So within this for loop, I'll just write to system dot out dot println, system dot out dot println. So I'll write main method. I'll write main method here. So simply I can write here run method. So simply I can write here run. So if I want to execute the run method, so I can call, so thread class object, thread class object. So T is equal to, so new thread, T is equal to new thread of new test class I will supply. And after that, T dot start method I should call. T dot start method should call. So you can observe the output. You can observe the output. So Java C space test and Java test. So first it has executed, so main method, and it has executed run method. So it has executed run method. So I can say main is a one process based execution and run is one process execution. So that means so run is completely depends on main process. So run method is completely depends on main. So this kind of execution is called as this kind of execution is called as process based execution. This kind of execution is called as process based execution. So you can also say so thread based execution, thread based execution. So if you want to see the thread based execution, so we can call this method called as sleep method. You can call this statement called as sleep method. So sleep is a method we need to supply the milliseconds in the format of long, and it is a static method, and it's a static method available class called as separate class available inside the class called as class. So what I would like to do is I will call like this thread dot sleep method I use thread dot sleep method I use. I'll use 350 milliseconds. I'll use 350 milliseconds. So now observe the output. So Java space dot Java and Java space test and Java space test. So main method I run method is executed. So main method I run method is executed. So let us assume 750 millisecond. 750 millisecond. So Java C and Java test. So you can observe now. You can observe now. So the time is taking now. So main method I run method. So main method I run method. So suppose for example, in between, so thread create and start method. It create a start method. So you can observe the output. You can observe the output here. So Java space tester, Java space tester. So executed successfully, and I can place inside the run method. I can place inside the run method. So Java space insert Java. So unreported exception, interrupted exception must be caught or declared to be thrown. So what I do is I'll write in try and catch. I'll write in try and catch. I'll write in try and catch. So go to thread dot slate. Go to filtered slave catch. Catch interrupted exception IE. So interruption exception IE. So IE dot print start press. Print start press. The print start press. So open and close. So CLS. So Java C test dot Java and Java space test. Java space test. So run method is executing slowly. So the same thing I will have to run inside. So for loop also I will have to run in for loop also. So just to start method I'll place in front before for loop. So just observe. So Java C test Java and Java space test and Java space test. So you can observe now. You can observe now. So first run method execution. Again it comes to the then run method, then main method. First run method, main method. Run method and main method. Run method and main method. So it is called as independent methods are executed simultaneously. That means the first method is executed run method and comes to main method. And again it will go to run method and it will go to run method again. So that means so there are two common areas. There are two common areas. So you can observe this is the main, this is the main, this is the main, and this is the run. And this is the run process. 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 If main contains five lines, if main contains five lines, if main contains five lines, and run also contains five lines. Run also contains five lines. A process execute, a processor execute, process based execution. So first it will execute main, first it will execute main. So this is the output main and after that it will execute run, run like this, run like this, run like this. So that means this entire run method, this entire run method, so completely depends on this entire run method, completely depends on main. It run this entire run method completely depends on main method. So because execution start from the main and comes to run. Start from the main and comes to run. So without executing the main method, so it is not possible to execute run method. So that is the reason why. So process-based execution it is not recommended. So it is not recommended. So because one process is depends on another process. So instead of execution of process, so we should use the thread classes. We should use the threads. So threads are simultaneously executable by one. So that is called as multi-thread programming. That is called as multi-thread programming. So what is multi-thread programming? Executing multiple threads simultaneously is called as multiple thread programming. So there are two ways to define the threads. So one is runnable interface and one is thread class. So what is the procedure? We should develop the program to implement runnable interface or externally thread class, or we should override the run method and we should call the start method. So how it is execute? So it will execute thread based execution. So independently. So first it will execute main method. Then it will go to run method. Again it will go to main method. So next it will execute run method. Again it will go to main method. So next it will go to run method. So like that. So it will execute. So it will execute. So from some statements from the main method, some statements from the main method, and some statements from the run method. So this is nothing but multi-thread programming. So this is nothing but multi-thread programming. So this is nothing but multi-thread programming. Executing multiple threads. So here, so main method and run method is declared as threads. So main method run method is declared as threads. So this is thread one, this is thread one, this is thread one, and this is thread two, and this is thread two. So there are two ways. So there are two ways. So executing multiple threads simultaneously is called as multiple threading programming. Multiple thread programming. So you can observe. So thread one is executed first and thread two executed next. And thread one executed first and thread two is executed. So next. So you can also declare any number of threads. You can also declare any number of threads. So I will show you. I will show you. So just I'll write so public class public start threads public class thread a demo thread a demo. So which extends which extends which extends a class called as thread. So a class called as thread demo. A class called as thread demo, which extend the a class called as thread, which a class called as thread. So there are two ways. The first one is implements runnable, implements runnable, and override a method called as run method. And we should call the method called as start method. We should call the method called as start method. So there are three steps. There are three steps. So we should write a Java program to implement runnable interface or thread class. So first program, so I have implemented using the runnable interface. I have using the runnable interface. So next I am using the thread class. Next I am using the thread class. So that is the reason why I have taken class called as thread demo and extend the class called as thread. Extend the class called as thread. So this is the first step. This is the first step. So what is the second step? We should override run method. We should override run method. So I'll write run method here. I'll write run method here. So public void run method. So public void run method. So inside this, so I can use system.out.println. System.out.println. So just run method. So just run method. So override run method is completed. Override run method is completed. So we should call the start method. We should call the start method. For that I'll declare main method. For that I'll declare main method. So string args. So open the main method right plus the main method. So open main method right plus the method. So start method is from a class called as thread class, a class called as thread class. So I'll just write T1 is equal to new thread. So new is equal to new thread. Or so instead of thread class, so directly you can use thread demo. Directly you can use thread demo. So thread demo is a subclass to a superclass called as thread class. So already we have discussed a topic called as exchange topic. So that is comes under inheritance. That is comes under inheritance. So what is inheritance? Inheritance is nothing but executing, creating multiple chain of object by using subclass object. We can also call subclass method as well as superclass method. Subclass method as well as superclass method. By creating this thread object, by creating the thread demo object, we can also call thread demo methods as well as thread class methods. We can also call thread demo object as well as thread class object. So I will write so T1 dot start or also you can use another thread. You can use another thread another thread T2. I can also call T2 dot start. I can also call T2 dot start. So just I'll execute. So just I'll execute. So based on which thread is executing. So based on which thread it is executing. So we can also display like this. So you can observe the output. So Java space thread demo. So Java space thread demo dot Java and Java space thread demo dot Java. So thread demo. So run method and run method is executed by so thread one and thread two. So on which basis the threads are executed. So you can also display the so maximum priority, so minimum priority, and the normal priority. And we have separate methods. And we have separate method. So you can display the current thread. You can display the current. You can also display the current thread. So current thread is nothing but a static method. Current method is nothing but static method. So you can write this. You can write this. So thread dot. You can also write this. So thread dot. You can also write this. So thread dot current thread. So thread dot current thread is a method. Current thread is a method. You can also call the thread dot current thread. So you can display the output. You can display the output. So Java secret demo dot Java and Java space thread demo. So first one is thread one. So which is I and main method. So what is this thread one and thread zero and five and main method? So we will discuss. So this is the thread name. This is the thread name and this is the priority. So this is the priority and this is the name of the thread. So thread zero is the name of the thread and this is the process and this is the priority is the file. So there are priorities for the threads. So there are priorities for the threads. So there are priorities. There are priorities. There are priorities. So there are priorities. Based on these priorities only, based on this priorities only, the threads will be executed by the process. Who are executing process? So threads are executed by the processes. Threads are executable, executable by the those threads are executed by thread processor. Processor. Threads are executed by the processor. And these threads, so and based on threads are executed by the processor and based on priority. So based on priority, threads will be executed. Threads will be executed. So based on priorities, based on priority, the threads will be executed. So threads are executed by the processor. Threads are executed by the processor, and these threads are executed based on the priority. Based on the priority. So there are three types of priority. There are three types of priority. So you can observe here. You can observe here. So maximum priority. So minimum priority and normal priority. So maximum priority, minimum priority, and normal priority. So these are the priorities. These are the priorities. These are the priorities. So normal priority, minimum priority, and maximum priority. Maximum priority. So minimum, maximum priorities. So minimum, maximum, and normal. So based on three parameters. So first one is minimum priority. Minimum priority. Minimum priority. The second one is maximum priority. The second one is maximum priority. Maximum priority. Minimum priority. So maximum priority and normal priority. And and normal priority. So normal priority. So minimum, maximum, and normal priority. And normal priority. normal priority, normal priority. So the default, so normal priority is 5 and the minimum priority is 1 or 0. So minimum priority is 0 and normal priority can be 5 and maximum priority can be so 10 or 15. So 10 or 15. So 0 minimum or 0 or 1. So 0 or 1 is the minimum priority and the normal priority is 5 and the maximum priority is 10. So let's assume 10. So based on these priorities, threads are executed by the processor. Threads are executed by the processor. Threads are executed by the processor. So next. So there are two ways. There are two ways. The first one is by extending the thread class. By extending the thread class, the first one is by implements the runnable interface. By implements the runnable interface. By implement the runnable interface. These are the two ways. These are the two ways to declare and to declare and so threads and execute. Thread and execution. Thread side execution. Thread side execution. No, this is called as thread lifecycle. There is a concept called as thread lifecycle. So this is what a thread lifecycle. What thread lifecycle. So you can see the states. So you have new state. You have new state. So this diagram will represent the states. These diagrams will represent the states. So this diagram will represent the state. So this diagram will represent the state. Okay. So observe the diagram and states. Observe the diagram and state. So there is a new state. There is a new state, and there is a runnable state, and there is a runnable state, and there is a running state, and there is a running state, and there is a termination or dead state. Termination or dead state, and there is a blocked state, and there is a blocked state, and there is a waiting state, and there is a waiting state, and there is a timed waiting. There is a timed waiting. So you can see the any diagram. You can see the any other diagram. So you have new state. So you have new state. You have new state, run-up state, a running state, waiting state, and dead state. Running state and dead state. So I can copy this. I can copy this. Press here and try to just here. So first, so right. So you have a new state. You have a new state. You have runnable. You have running. You have waiting, and you have dead. So these are states are called as life cycle of myth or life cycle of threats. These are called as life cycle of threats. Threat life cycle, or you can call threat life cycle. 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 So there is a start method. There is a start method, and there is a run method, and there is a sleep method, or there is a wait method. Okay. So, and we have created the new thread, and we have created the new thread. So you can observe the thread, new thread. Observe the new thread. So in this program, or in this program, or in this the test class program, this the thread demo class. Simply, simply. So I can copy the program here. I can copy the program here. So simply. So just so new state is nothing but new state is nothing but creating the threads. Creating the threads is called as new state. Is called as new state, and runnable. So declaring the runnable is called as another state, and calling start is called as another state. Okay. For clear demonstration, I'll write again. So same. Uh, this is another state. Okay. Simply. This is the run. We will find there. So this is one step. This is one step, and this is another step, and this is another step, and this is also one step, and this is also step. So new state. So new state. So new step is nothing but this one. So new step. When you create the test class object, it is a new step. When you create test or thread demo object, it is a new step. It is a new step. Right. When you call a start method, when you call a start method, when you call a start, When we call a start method, it is runnable state. It is runnable state. When you call a run method, when it executes run method, it is running state. It is running state. It is running state. And when you call sleep method, when you call sleep method, okay. So we have a sleep method in another example. We have sleep method in another example. So I can copy this. I can copy this. I'll paste here. I'll paste here. Just a minute. Setting. No. Just now this. Okay. Just the program. Just run method. Sleep. Okay. Okay. Sure. This is new when I create a thread and when you call start method and this is runnable and this is runnable. And when the run method is executed, it is running. When we call sleep method, it is waiting. Is waiting. So this is life cycle of after execution is completed, that is dead state. After execution is completed, that is dead state. That is dead state. That is dead state. So these are the life cycle of threads. These are the life cycle of threads. So when you create a thread plus object, when you create a thread plus object, that is a new state. That is a new state. So this is new state. This new state. When we call a start method, this is runnable state. And when you execute the run method, it is a running state. It is running state. When we call sleep method, when you call sleep method, so it is nothing but waiting state. It is nothing but waiting state. It is nothing but waiting state. And we have the concept called as deadlock also. And we have the concept called as deadlock also. So I will demonstrate the uh, deadlock situation. I will demonstrate the deadlock situation. So clearly, deadlocks clearly. So we can observe this. You can observe this. You can observe this. You can observe this. So just a new file taking. So new file. I'm taking. I'll save the file. I'll save the file. So okay. Okay. So just so we have thread one and thread. We have thread one and thread two. So if thread one and thread two are waiting, if thread one is waiting and thread two will require the lock. So let us assume this is a thread one. This is thread one. So I'll choose the color. So this is thread 1 and this is thread. So thread 1 and thread 2. So I'll write clearly thread 1 and thread. Thread 1, right? Oh. So let us assume. So let us assume thread 1 and thread 2 are available. Thread 1 and thread 2 are available. So it will share the common resource set. So let us assume a memory resource, resource, memory memory resource. It is a common memory resource. First, thread will enter. First, thread will enter to execute the memory resource. First, thread will enter to execute the memory resource. After some amount of time, after amount of time, thread will enter into waiting state. Thread will enter into waiting state. I'll show you now. There are different states: new, runnable, running, and wait. Okay. So now, after execution completion of the thread one, thread will enter into waiting state. Thread will enter into waiting state. So let us assume this is waiting state. This is waiting state. So first thread will enter into a memory resource area. So thread will execute the memory after some amount of time. So thread time is completed. So thread time is completed. So it will enter into waiting state. It will enter into waiting state. Will enter into waiting state. Enter into waiting state. It will enter into waiting state. So that so that so this execution time is completed. So this execution time is completed. So now thread 2 now first thread 1 will enter into waiting state. Now thread 2 will share the memory resource area. Thread 2 will share the memory resource area. After thread 2 execution is completed, after thread 2 execution is completed, again thread 2 will lose the collection and thread 2 wait into the waiting state and thread 1 will complete. So if thread 1 is completed, thread 1 will enter into the waiting state and thread 2 will execute. So that means one thread should be in waiting state and one thread should be in memory resource area. If thread 1 is waiting in waiting state, the thread 2 should be invoked. The thread 2 should be invoked. So what is the context? What is the construct here? If thread 1 in memory area, thread 2 in waiting. Or if thread 2 in memory area, so thread 1 should wait. That means if one thread will able to execute the resources, another thread should be waiting. And, and if thread 1 is waiting in waiting state, the thread 1 should invoke. The thread 1 should invoke. If thread 1 is waiting state, the thread 2 should invoke. So there are two terms. Wait and wait and invoke. Wait and invoke. If one thread is in wait, another thread should be invoked from the waiting state. So let us assume wait and invoke. So wait and invoke. Wait and invoke. Wait and invoke. So wait and invoke. If thread 1 enter into the waiting state, if thread 1 enter into the waiting state, the thread 2 is executing the memory area. After execution is completion of thread 2, after execution is completed of thread 2, the thread 2 will go to the waiting state and invoke the thread 1. So that is what acquired. So thread 1 is acquired. After acquisition, thread execute the process. After execution is completed, so thread 1 will enter into waiting state and it is locked. From the locked, it should be acquired thread 2 and thread 2 will execute the process and it will go to the waiting state. So that means so thread 1 should invoke. So what is the process? Thread 1 will execute, thread 1 will execute and thread 2 will wait. And thread 2 will wait. And after that, so thread 1 will execute the resource, will execute the resource, will execute the resource, and thread 2 will wait. So in the next step, thread 1 will invoke, thread 1 will invoke thread 2, thread 1 will invoke thread 2, and thread 1 will enter into thread 1 will enter into waiting state. Enter into waiting state. Thread 1 will enter into waiting state. So what is the procedure? So thread 1 will execute the resources and thread 2 will wait. If thread 1 will invoke thread 2, the thread 1 will enter into waiting state. Then thread 2 will execute, thread 2 will execute the resource. Thread 1 will execute the resource and thread 1 will enter into or thread 1 will enter into waiting state. Thread 1 will in waiting state. If two, so one should be execute, one should be in execute, one should be in execute, and another one should be in waiting state. Another one should be in waiting state. If one thread should be in execute, another thread. If one thread should execute, what is the motto? If one thread should be in execute, another thread should be waiting. Another thread should be waiting. So this is the main motto. So forget about these lines. So we will get confusion. We will get confusion. So if one thread should be execute and another thread be in wait. And one thread, if one thread invoke another thread. So one thread invoke, one thread invoke another thread. If one thread should be in execute and one thread should be waiting. So one thread invoke another thread. So if two threads, two threads enter into waiting state, the two threads enter into waiting state, waiting state, and and waiting for or looking for, waiting or looking for invoke each other, invoke each other, invoke each, invoke themselves or invoke themselves, themselves is called as deadlock, is called as deadlock, is called as deadlock. So actually speak, one thread should invoke another thread actually. And if two or more threads or two or all threads, two or all threads enter into waiting state and looking for invoke themselves is called as deadlock. That means there is no threads. There is no threads. Invoke another threads. There are no threads to invoke another threads. So two or all the threads enter into waiting state and looking for invoke themselves is called as deadlock. So in order to demonstrate the deadlock, in order to demonstrate the deadlock in Java, so we have the program. We have the program. So deadlock in Java. So you can see the output here. So thread one should invoke the thread two. So thread one should invoke the thread two. So thread one lock of thread. So you can observe the code here. So just I'll copy the code. Just I'll copy the code. So just copy the code. So I'll take a new program. I'll take a new program. So I'll test Deadlock example. I'll save the file. I'll save the file here. So file, so save the file, save. So deadlock example one dot jar. Deadlock example one dot jar. So this is the main method. So this is the main method, and there are three resources, two resources, resource one and resource two. So just example. So I'll write. So kite and kite omens and kite omens. So there are three resources. There are three resources. So two resources. So resource one is kite and resource one is kite W. So I have created one thread class here. I have override the run method and I have used the synchronized keyword. I have used the synchronized keyword. So what is the synchronized keyword? The synchronization is a keyword. So it is used for the synchronization. It is used for the synchronization. What is the meaning of synchronization? So restricting. So multiple threads enter into same resources. Restricting multiple threads enter into creating common resources. So it is the restriction of multiple threads, multiple threads enter into multiple threads enter into common resource area, enter into common resource area, common so resource a memory or area is called as synchronization. So restriction of multiple threads enter into common resource areas is called as synchronization, is called as synchronization, is called as synchronization. So synchronization, so it is able to, so synchronization, it is able to, so restriction of synchronization, it is nothing but so restriction of multiple threads enter into common resource area synchronization. So this synchronization is possible by using the synchronized keyword, by using the synchronized keyword. So mean this resource one cannot be shared with multiple threads, cannot be shared with multiple threads, so cannot be shared, so cannot be, so share, cannot be shared with multiple threads, with multiple threads, with multiple threads at a time, at a time, at a time. So we cannot share multiple times, multiple threads at a time. So it is called as synchronization. Cannot be shared with multiple threads at a time. Is called as synchronization or restriction of multiple threads enter into common resource area is called as synchronization. So that is what about the synchronizer. And already we have discussed that sleep method. So until this particular amount of milliseconds, the thread execution will stop off. So there are two threads are created. So thread one and thread two. Thread one and thread two. So this is also wait for 1000 milliseconds. So after that we should call the start method. After that we should call the start method. So run method within the run method. So I have created the synchronized resources one, resources two. So I'll execute the program. I'll execute the program. So Java C. So Java C space. So Java C space. What is the program? So Java C space test deadlock. Test deadlock example one. And after that, test example one. Test example one dot class. So thread one locked resource one and thread 2 log resource 2. So it is blinking. It is blinking. It is blinking. The meaning is the thread 1 is enter into waiting state as well as thread 2 is also enter into waiting state. So it is waiting for each other. It is waiting for each other is called as deadlock. Is called as deadlock. So mandatory that we should invoke the mandatory that we should invoke the threads. So we should not enter into threads actually. So this is the thread one. So we can also some more methods. You can also have some more methods. You can also have some more methods here. So I will show you some methods here. I will show you some methods here. So is a demon thread is called as demon thread. So what is the demon thread? So demon thread is a parent connected child thread. It is a child. There are demon thread. Demon thread. So what is demon thread? So child thread, if child thread, if child thread is connected with is connected with is connected with the parent child is called as parent parent thread. The child thread is connected with such parent thread is called as demo thread. So deadlock is called as so one thread in execute and another thread should in waiting state. If one thread execute another thread. If two or all thread enter into waiting state, so this is called as deadlock. This is called as deadlock. And the synchronization is nothing but so restriction of multiple threads enter into same resource area cannot be shared with multiple threads at a time. And demon thread is what? If child thread is connected with the parent child. So multi-threading and the thread concept. So life cycle of threads are nothing but new runnable running. And there are some methods. There are some methods. So we have the giant method. We have the giant method, and we have the interrupted method. We have the interrupted method. So we can have the get name method. We can have the get name method, and also we can call, and also we can call the methods like. No, also we can call the method like. So finalize method. So finalize method to calculate and notify method, notify all method and wait method, the wait for some time. So the causes current to wait until and unless invoke the notify. So there are some methods. There are some methods. So sleep method. So sleep method. So sleep method. So which takes time. Sleep method which takes time. And wait method also which takes time. And wait method also which takes time. And notify method I notify all method. Notify all method. So there are two methods and notify all method. So it invoke single thread. It will invoke single thread. Wait, it will invoke single thread from the waiting state. It will invoke single thread from the waiting state. Single thread from the waiting state. Single thread from the waiting state. A single thread from the waiting state. So simply I can write here. Simply I can write here. So sleep method. So we can mention the particular time, and wait method. So we can also mention the time, and notify method. I notify all. I notify all. So this method invokes all threads from waiting state, all threads from waiting state. And this method invokes this method invokes a single thread. So single thread. So from waiting state, from waiting state, from waiting state. So single method for single thread we use in notify method. For multiple threads wait invokes we use notify all method. So this wait method this wait method causes uh, wait a thread, wait a thread, wait a thread in waiting state, in waiting state, wait a thread in waiting state until until unless until until we call notify or notify all. Notify or notify all method. Notify all method. Notify all method. Notify all methods. So wait method by using wait method. So by using wait method, so that causes a wait into waiting state until unless we call the notifier note. So this method causes weighted thread into this method. It causes it causes it causes weighted method or weighted thread in waiting state until specified time is specified time is expired. So specified time is expired. Specified time is expires. Specified time is expired. That means automatically automatically invokes from waiting state after time expires, after time expires. So that is the difference between, so wait, that is the between, so wait, notify all, notify all. So sleep method, so by using sleep method, the thread will be so invoked automatically when the time is expired. The wait method will be waiting until unless, so notify all method will be called. So by using notify, so we can invoke a single thread from the waiting state. By using notify all, so we can invoke all the threads from the waiting state. So this is about thread reference something, but so multi-thread programming. So program can be converted into processes can be converted into threads. So this is a, so we need to write the concept in the deadlock life cycle method. So there are two ways: runnable thread class and run method and start. So this is how you need to call the so start method, and this is how you need to write the run method for each and every. And you have to use the sleep method or wait method. You can use the sleep method or wait method. You can use the sleep method or wait method. So this is how the thread concept is there. Okay, so end of this. So we will continue in the next class.